All right, let's finish off this section of chemistry in the first unit with our section 2.1 or 2.3, sorry, on understanding exposure. So there's going to be no calculations, I don't think, as far as I know, going through this. Just showing you some terms and what some of this stuff means. So exposure to certain chemicals, organic chemicals in general, so those carbon-based gases and stuff like that. So here it says off-gassing, and this is a word that you likely come across in your life, or you will. And the definition of off-gassing is the release of volatile organic compounds. VOCs is short for volatile organic compounds from building materials. So this is fumes. So an example is the smell of paint. So those fumes that you smell when you put paint on the wall. Those fumes you smell when you open, I don't know, you get a new shirt or you open up something that's plastic. You smell that, like, I don't know, I want to say, we sometimes talk about that new car smell, or that the smell of these chemicals. Basically, it's that off-gassing. So it's the smell that these chemicals give off. The concerns about this is that they make air quality quite poor and they can trigger allergic reactions. So that smell that you smell, it could be make someone have an allergic reaction, not necessarily a good thing. So just by going through those two things, there's some questions, question number 25 and 26 on page 280 that I would like you to do. The next term is pesticides, and you might know what these are. These are substances used to kill pests like fungus, insects, animals, etc. And the types of pesticides, I guess it skips that. But on your booklet, there's types of pesticides. So seeing the chart, it shows and explains sort of what these things are. So insecticides, what those are, they basically kill insects or damage them. And this is because insects can damage agriculture, forestry, and cause disease in these things. So these insecticides kill the insects. Herbicides are things that kill plants or things, unwanted plants. So insecticides, herbicides, and then fungicides. So when you see that root word or the end of the word that says sides, so side means to kill, and so insecticides is to kill insects, herbicides kill herbs, and fungicides to kill fungus. Okay, so that word means kill. Okay. So there's a little chart in your notes on that. So we'll continue on. Considerations when using pesticides, we need to specify our target. So we need to figure out what our range of organisms affected by the pesticide. So if you use something that kills everything, well, that might not be what you want. You might only want to kill a specific thing. So you need to figure out what your target is. And these different pesticides, there is ones that target specific things. And then the second thing here is broad spectrum. And those are ones that they basically just kill everything. So a product that has a low target specificity and will act more generally affecting many species. So a target, I know this from using it in the summer. A target specific, an example that I use on my lawn is called Killex. I don't know what the chemical of Killex is. Something glycophosphate, I believe. So that's the brand of it, Killex, and that kills weeds in your lawn. So like broadleafed, I think, weeds is what it actually says on the packaging. So it kills like those sort of like prickly thistles and dandelions. It kills those. So broadleaf weeds. Okay, what it doesn't kill is the grass. So I could spray this all over my whole lawn and it's gonna kill all the weeds, but it's gonna not kill the grass. So that's a great thing, because if I sprayed something that killed the grass too, well, then my whole lawn is brown, and that basically defeated the purpose of what I was trying to do. So a broad spectrum pesticide that we often see is called Roundup. And Roundup you can also buy at Canadian Tire, probably just beside the Killex. That's also the brand name. And that has the chemical in it DDT, which is also a short form for a very long chemical name. But this Roundup actually kills everything. Well, I don't want to say everything. Kills plants. All plants. And they used this in the Vietnam War, I believe, where they would spray it. They called it Agent Orange. And they sprayed it from helicopters or planes up above. And basically it would kill all of the leaves and stuff, all the plants in the area, and would expose the enemy. And people have long lasting effects of DDT. It's actually, they found out it's a very terrible thing. So this is not a good thing to use on your lawn. To be honest, I also used this in my garden this summer. When plants sort of were growing up where I didn't want them, I would just spray it directly on that plant. There was no grass in the area, but if I put it along the edge of my garden, I ended up killing some of the grass. I also didn't realize that this was broad spectrum the first time I used it, and I sprayed it on dandelions in my yard, and then it made just little dead patches. So it killed the grass around it and the dandelions. So a broad spectrum pesticide, this is one you would use when there's no grass around. So maybe like on your sidewalk or something where weeds are growing through. Okay, so target, it has a specific target. Broad spectrum kills mostly everything that it comes in contact with. Toxicity, that the definition is the ability of a substance to cause damage to living tissue, impair body systems, or cause death. So something being very toxic, we already know what that basically is. If you ingest anything that's toxic, you are possibly gonna be sick, impair you in some way, or depending on how toxic it is, cause death. It says take some time to do some review questions. I'm not sure which review questions it's asking you to do because we don't have any of those in our booklet, so I'm going to say don't do that, and we're just gonna continue on. Okay. So the next definitions are LD50 and LC50, and what these things are the amount of chemical basically in the thing that's going to kill 50% of the population. So it says the amount of chemical that kills half of the tested population. So you can see this LD50 written on certain chemicals that you find in the store, and that's basically telling you its effectiveness. LC50 is the amount of chemical in the air or water that kills half of the tested population. So that LD is the chemical just in the population. LC is looking at it in the air and water. So all of these things, the combined effects of using these sort of chemicals, it's not routinely tested for the effects on human, and absorption of some of these pesticides through the skin is higher when you're wearing sunscreen, and typically people tend to be using these things outside in the hot summer and tend to be using sunscreen. If you look at some of the data for DDT or 2,4-D in your notes, it actually shows you how effective or how much you would need of a chemical of 2,4-D to kill a aquatic vertebrate, a rainbow trout, a frog, earthworm, quail, mallard duck, mouse, and rat. So these things are living in the environment, and we're putting these chemicals onto the soil, so it's showing how much milligrams in a liter of water or milligrams per kilogram of soil that these things would need to ingest to be dead, which is not good. The next definition is drift, grasshopper effect, and persistence. So drift, that is defined as the transfer of pesticides by wind or air, to other locations. So drifting through the air, a pesticide can move. It says toxins can be transported into water and affect water, aquatic life, and us. So there's many concerns about these toxins drifting from one thing to the other. So it doesn't, I was right when I said water here, but they don't add it in. I'm not sure why. I will put water as well. So there's many concerns with drifting or things spreading. The grasshopper effect is the transport of pesticides that are evaporated in warm weather and condense in colder climates, so at the North and South Pole. So for us, this isn't great. If there's lots of pesticides being used in the States, for instance, in warmer areas, let's say Texas, they're a lot warmer there. Well, the air can travel up towards the poles, and we're closer to the North Pole. And then as it gets closer up here, the air gets colder and it condenses and rains back down. So we end up getting these pesticides being put onto our soil instead of where they were originally put out. It says take some time to do some review. We're just going to keep going. And then persistence is the difficulty for breaking down chemical substances naturally or chemically. These are heavy metal leaching and biomagnification. So persistence means basically when something is persisting, it's staying in the soil, it's staying around. It doesn't just go away. So that's that difficulty of things being able to break it down. We have lots of bacteria, fungus in the soil that can help break down some of these chemicals. That's called phytoremediation. But we have some concerns with heavy metals. Heavy metals aren't going to break down, and then biomagnification. We talked about possibly in Science 20 or Bio 20, depending on which one you took. But that means as things go up the food chain, they magnify. So as as you go up the food chain, there's more pollutants or toxins inside the body of organisms. Okay. In the past, I gave you the example of, like, there's 5 small fish, or 3 small fish, and then there's let's say each of these have one molecule of toxins inside their body. Then these other fish come along. That's not a fish. Those two bigger fish come along and they eat two of these fish. So now each of these fish have two toxins inside their body, right? Because they eat this guy's and these guys. This guy he's safe, I guess. And then another fish comes along, an even bigger fish, and he eats these two big fish, these blue fish, and now he's got 4 toxins inside of his body. So that's what biomagnification is. So as things go up the food chain, they become to have more and more concentration of these toxins inside their body. Water quality. So fertilizers and organic matter, how do they affect water quality? Well, they contribute to algal blooms and eutrophication of lakes. This can have excessive plant growth because of higher nutrients. Fertilizers and organic matter promote plant growth because of nitrogen and phosphorus. So what that all means is that when we dump fertilizers or we put fertilizers on our soil, water can rain down from the sky and carries those fertilizers into lakes, ponds, rivers, oceans, whatever kind of water body. And those nitrogens and extra fertilizer in the water creates algae. And when we see algae can take over areas, and it basically reduces the oxygen for fish and different things to live in the water. So algae can create dead areas. They call them dead zones. They're dead except for the algae. So the algae it's sort of like an invader. It takes over an area and wipes out everything else in the area, and that creates a dead zone just because of us putting excessive fertilizers on our soil. So something that's a really bad contributor to fertilizers and algae blooms is golf courses, because golf courses, they have those beautiful green soil. They're always putting so much fertilizer on, watering it. It rains, it pulls all of those fertilizers into bodies of water nearby, and then you've got these big algae blooms. Not something that you want to swim in, not something that fish or anything can live in, because the algae is taking up all the oxygen. As far as swimming in it, humans living by lakes that have algae blooms, it can cause skin irritation, sore eyes, and swollen lips. What is BOD? This is biological oxygen demand. What does a high BOD mean in terms of water quality? It means there's not a lot of dissolved oxygen, and this can be very unhealthy. So this is what algae would do. It's going to require a lot of oxygen, so then it's going to steal it from the other organisms in the water. What is the biggest concern of releasing raw sewage into water supplies? Well, it's exposure to disease causing viruses and bacteria. So as well as putting fertilizers into the soil, if we put sewage, that's also going to cause an algae bloom. Excuse me. So when we put our raw sewage into the water, we also, through our pee and poop, will give off nutrients, and then that'll create algae as well. So algae blooms, it gives it like extra fertilizer that it doesn't need. So here's a question that you need to do 289 on page 289, question number 30. And then we're going to do our last word here, our last vocabulary word, which is resistance. So resistance describes how a population may result due to pesticide use. So how resistant are you? Are you going to be able to withstand the effects? So when we rely too heavily on a product like pesticides, pests can become immune to and grow accustomed to the pesticide. It's important to use multiple types and varieties of pesticides so that you don't create an immunity. You might know this or have heard of this when you're talking about antibiotics. If you're sick, if you don't take all of the full amount of your antibiotics, the bacteria in your body can produce a resistance, and then the next time you try and take those antibiotics, well, they're not going to work at all. So that's the same with pesticides. We need to change up the amount of pesticides or the ones we use so that we don't create a resistance in our pests, and then it's going to make it even more difficult for us to be able to get rid of them. Okay? So varieties of pesticides. Other than that, that's it. So that's our exposure. So that's just a bunch of terms that you should know what they mean. And that is the end of our chemistry unit. You should be doing the review at the end of this. So this reviews you. And then your test for chemistry will be put onto the Google Classroom next week, at the first of the week. Probably Monday or Tuesday, and you will have until the end of the week, or the full week actually. I believe you will I'll give you a full week to do your test, but we're going to be moving on to the biology section starting Tuesday. All right, so have a great Thanksgiving weekend, and hope to hear from you all soon.